right, Precalc, so we're continuing. We are in lesson 8.5, and we're still working with permutations. And we're going to start, we've already done example 6, so we're going to start with example 7 right here. It says a coin club has 5 members. In how many ways can a president and a vice president be selected from its members? So remember, permutations have this formula, NPR, and you know where to find that on your calculator, so you're going to hit on your TI-84 for those of you that weren't with us yesterday. You're going to hit math and scroll to the right to probability, and at number 2 it says NPR. And we have n factorial over n minus r factorial. So we know that we have 5 members and we need a vice president and a president. Does order matter? Yes, in this case order matters, so it's going to be a permutation in the fact that we're in the permutation section. And remember, I taught you something a little different. So I told you you can take 5 factorial, 5, 4, 3, 2, 1. And you could do 5 minus 2 factorial, which is 3, 2, 1. And I told you that works. That's great. And you get the answer of 20. But the way I teach this is take the 5 factorial only 2 times. So that's going to also be 20. All right, so here's a bunch of us to focus on. 8, permutation 3. And I do ask that you try to do these by hand before you try to go ahead and put them all in a calculator. Calculator practice is good to make sure you know how to do it, but doing them by hand is even better. So this is saying we're going to take 8 factorial 3 times, and my answer is 336. B, we just did that one. This is saying 5 factorial 2 times, the answer was 20. And the last one, this is just saying, hey, 3 factorial 1 time, and you could put this in your calculator if you don't trust me. The answer is just 3. We're going to move on to a new concept. This new concept is called distinguishable permutations. Suppose a set of n objects has n sub 1 of one kind of object, n sub 2 of a second kind, n sub 3 of a third kind, and so on. The number of distinguishable permutations of the n object is given by n factorial over all of them. What does this mean? Let's talk about what it means. Okay, we're looking at the word banana. So it says, in how many ways, let me say that again, in how many distinguishable ways can the letters in banana be written? So we're going to take, let's see, 1, 2, 3, 4, 5, 6 factorial, and I'm just going to write that out. And anything that's repeated, 1, 2, 3. Notice we have 3 repeaters of A, so I need a 3 factorial, and another repeater, and N, I need a 2 factorial. So this would just be 6 factorial over 3 factorial, 2 factorial. I could do the B as 1, but do I need it? No, because 1 factorial is just equal to 1. So let's cross out what we know. 3, 2, 1 will cancel out. 2 goes into 4 2 times. And 30 times 2 is 60. So there are 60 distinguishable ways that we can rewrite the letter that we could rewrite banana. All right, it says find the number of distinguishable permutations of this group of letters. AA, EEE, J, PP, RR. So let's write what we'll need. How many letters total? 1, 2, 3, 4, 5, 6, 7, 8, 9 factorial. And then I have a 2 factorial here, a 3 factorial here, and a 2 factorial here. So I'm going to give you a second to put this in your calculator. Don't forget, if you put this in your calculator, you do want to either open the fraction or open and close a parenthesis in the numerator and open and close a parenthesis in the denominator. So the answer to this is 15,120. From here, I like to see my students put their names. My name isn't very exciting, but I'll do it anyway. My last name is Maloney. And notice I have no repeaters, so that's just going to be over 1. But how many letters do I have? 1, 2, 3, 4, 5, 6, 7. So my distinguishable is going to be 7, hit math, scroll to probability, number 4 is the factorial, 5,040. So I always have everybody come up to the board and we do a competition, whoever has the largest and whoever has the smallest. It is never me. Anyways, try your name. It's super fun. Great job.